Go. Okay. So look, you guys, this is 127, page 127 in your comp book. Are you there yet? If you're there, turn to page 127. If you're not, go to creatormath.com and pull up page 127 as we go over these notes, right? This is on congruency number 2. You're in a new unit on congruency. The big question in your mind, I hope right now is, what is congruency? When you think of congruency in terms of geometry, right? You're in geometry class, switch to that meaning. Maybe it means something otherwise in your life, but switch to geometry for congruency. What does it mean in geometry? What does congruency mean? If you read the notes, if you took the notes, right, you're looking at these, what I hope you could take away from this is that two shapes are the same. It's okay? So if you're looking at two triangles, right, you're going, are these two triangles congruent? You're asking, are they exactly the same size? Now, why don't we just say equal? Why don't we say, are these two triangles equal? Here's my 2 cents worth on that, right? Equal is a single understanding. Is 3 equal to 3? Right? Yes. One thing equal to each other. 3 is equal to 3. You okay with this? But look at the triangle. You've got side lengths, 3 of them, and you've got angles, 3 of them. When you ask if this triangle is equal or the same as this one, you're not just asking is 3 equal to 3. You're asking, is this angle equal to this one? Is this angle equal to this one? And is this angle equal to this one? Are you with me on that? 3 separate angles you're thinking about, right? Is this angle equal to this one? Is this angle equal to that one? And is this angle equal to this one? What's the relationship? Number 1, they correspond in location to each other. So you'll see the word corresponding in here. You're talking about, does this angle match up with this angle? Do they correspond in location with each other? That means, are they a matching location on 2 separate shapes? You okay with this? Then you're looking at side lengths. Does this side length equal this side length? Does this side length equal this side length? Does this side length equal this one? Do you see how complicated it is now? You're not just asking, is 3 equal to 3? That's really simple, right? Yes, it is. But is this triangle equal or congruent to this one? Now it's a lot more complicated. Are you seeing the additional complexity, right? Because of 3 angles, because of 3 side lengths, you're now talking about a much more dynamic problem in your mind, right? Are these 2 triangles exactly the same? So now you have to go through the congruency process, which I would argue to you, congruency means multiple aspects of equality. Not just one. Not just is 3 equal to 3, but are all these aspects of each triangle equal to the corresponding or matching locations on the other triangle? Okay, with all that said, you're going to use Schoology to start to interact with the vocabulary and try to ask yourself, are these 2 triangles congruent? In this case, for this lesson. All right, so here's the setup question. Given 2 triangles with the same corresponding side lengths, separated by equal corresponding included angles, what can we say about the 2 triangles? And we're going to be able to say they are congruent or they're not congruent. They are the same or they're not the same. That's what we're trying to say. So here's what we're talking about today. In today's lesson, it's called SAS, side angle side, congruency postulate. And if you notice, the vocabulary is rich right now. There's a lot of new vocabulary going on in this, right? But here's what it means. Given 2 triangles, so we're looking at 2 triangles, with 2 pairs of corresponding sides that are equal lengths. So if I can match up this side as AB and this one as DE, I can match up this one as BC and this as EF. See how these 2 sides are an equal length? 2 tick marks here means that that's the same length as this one with 2 tick marks. And then I'm looking at this side with 3 tick marks, equal in length to this one. So this side's equal to this one, this side's equal to this one, and the angle that's included between the 2. What does included mean? If these are the 2 sides, the angle here is the included angle. So the triangle has other angles here and here, but they're not included in between those 2 sides. Does this make sense? What included means? Those might be excluded right there. They're outside, these 2 are. We're not interested in them. We're interested in the one included between the 2 sides in question for this postulate to determine congruency, right? So corresponding pair of sides equal lengths, all right, and equal included angles, they are congruent. If we can show this side is equal to that one, this side's equal to that one, and the included angle between them, see how there's 3 tick marks here and 3 tick marks here? That means those angles are the exact same measure. Then we can say these two triangles are congruent. Why? By the side angle side congruency postulate. So think about the name of this. It's got a side, it's got an angle between it, and a side. That's why it's called side angle side, and you're going to abbreviate it SAS, side angle side, because you're going to get tired of saying side angle side all the time, so you're going to abbreviate it to SAS, congruency postulate. What is a postulate? If you remember back from our earlier lessons, maybe, I hope, postulate is a definition, right? This is a definition. A theorem is the other side of a postulate. A theorem is made up of postulates. So if you can have a bunch of definitions and now prove something, it can become a theorem. But in this case, it's a definition. If we have this situation, that's why we're going to refer to this as a postulate in this case, all right? How do you write this? You say triangle ABC, which is this one, triangle ABC. Notice the triangle symbol. Notice the new symbol for you, which is congruency. It's not just an equals. Like if you said 3 equal 3, you would put an equals between it, right? But now you've got this squiggly line. See the squiggly line above the equals? This means there's multiple aspects of equality. This triangle ABC is equal to or congruent to triangle DEF. That's how it's going to be written with a brand new symbol for you. And equals with a squiggly over it. Okay, I'm assuming maybe you've never seen that before. Some of you might have in prior classes. If not, you've got a brand new symbol to put into your library, all right? And it's called congruency. If you're taking notes, I put these in there just to remind you. In your notes, you'll see these clouds. That's for focus note-taking. That's for you to summarize what it says here, right? Summarize in your own words. And there's rectangles in there for connect to prior knowledge. Some of you will have had some of this material in prior classes, right? So you're going to connect. You're going to go, oh, I remember in my math class last year, we did something similar to this and it looked like this, right? Put that into the rectangles for your focus note-taking. All right, go to the second example in this lesson. The example is here. Now you don't have symbols, so we don't have tick marks that match up. We have actual numbers of lengths. The length of side AB is 5. The length of AC is 12. The included angle between it is an equal measure to this included angle between a 5 and a 12. Now, do these two triangles look equal size to you? Everybody look at these two triangles. Do they look equal size to you? No. Why? They are not drawn to scale. Does this make sense to you? You know how you look at a map like Google Maps? It's got a scale to it. It goes this way and that way very deliberately, right? If they don't do the right measurement, it's not right according to how far something is, according to the scale of the map. You're going to get pictures of two triangles that are not drawn to scale on purpose. They're going to make them look different. But the question they're asking you is, are they exactly the same? They don't want you to look at them and go, oh, they're different sizes, they're not congruent. They want you to use the congruency postulate to determine yes, they are, or no, they're not. Does this make sense? So they're deliberately going to make them different sizes. Just imagine one is really close to you, so it's bigger, and the other's really far from you, and so it's smaller. Even though when you put them right together, they would be the exact same size. Does that make sense? Right? So they're going to go, right, in different scales, so to mess with your mind, to force you to use the postulate, not to use your eye anymore. Now you're going to use the reason, not the way it looks. You know, this does start to link up a little bit with a court of law, right? When you watch those court shows, you watch Law and Order, right? Have you ever heard of circumstantial evidence? Have you heard of this? Okay, circumstantial evidence is like a person is in the area where the crime happened. So maybe they did it, maybe they didn't. It's circumstantial. Nobody saw them do it, right? There's no eyewitness, there's no additional evidence, it's just circumstantial, right? Does that mean they did it? Maybe, maybe not, we don't know, right? So, but when you use the word circumstantial evidence, everybody in the courtroom knows because you're using a common language. That's what this side angle side is. It's now a whole meaning for you. When you say they're congruent by SAS congruency postulate, Everybody in the room is starting to look, as long as we know this, right? We went to law school, we know what circumstantial evidence is, we went to geometry class, now we start to know, oh, you're using the reason side, angle, side. Now I'm looking for these to be congruent. I'm looking for, do I have a side that matches up with a side? I do. Do I have an included angle between the two sides in question? I do. Do I have now the other side, 12, that matches up with the other side? Now, I would have had to flip this in my mind and ignore the fact that they're drawn to different scales, but I can start to see side, angle, side, side, angle, side, and I know that this congruency postulate is true. That makes these two triangles congruent. Now I can use that as my reason to state triangle ABC is congruent to triangle DEF. Okay, is this okay? Now what I didn't show you yesterday, actually go ahead and stop this.